Okay, so let's move on. I hope you are ready for some practice problems. Bring out your calculators, notebook or sketch papers, and ball pens. Okay, so I will show you one problem, one sample problem, and then after we solve this problem, you will answer a written work activity by group. Okay, so for the activity later, the class will be divided into 6. Okay, so what you're gonna do is you'll divide the class using your class list. So no shuffling, no shuffling, no randomization whatsoever. Just simply divide the class based on the class list. So based on your class number, for example, you are 40 or 38, for example. 38 divided by 6. And then from the class list, class number 1, let's say one group has 6 members. So class numbers 1 to 6 would be group 1. And then class number 7 to 12 would be group 2. And then so on and so forth. Okay? Do not shuffle anymore to lessen the hassle. Okay, and then we'll answer the first. So for example, here we have we're gonna solve for the force between 2-point charges. 2-point charges Q1 and Q2. Q1 having a charge of positive 25 nanocoulombs, and Q2 having a charge of negative 75 nanocoulombs, and they are separated by a distance r, which is 3 centimeters. Find the magnitude and the direction of the electric force that Q1 exerts on Q2, and in B, the force that Q2 exerts on Q1, vice versa. So first, before you solve, you have to evaluate the given charges, and you are given a positive and a negative. And so you will immediately conclude, based on the charges or signs, that the type of force present would be attractive force. Okay, so we will focus on this one. Okay, an attractive force. And we will use the Coulomb's law for this problem. All right. Next. All right, so this is the figure that we will consider. But before we solve, we have to make sure that the values are in SI. It's a regular thing, right? So the given values are in nanocoulombs. So we have to convert. And the conversion factor that we'll use is in 1 nanocoulomb, there is 1 times 10 raised to negative 9 coulombs. Okay, so this is our conversion factor. Oops, hold on. All right, again, I'll just present for a while. Give me a few minutes. Okay, I hope. Hold on. Okay, going back. So we will have to write all the given values first. So we have Q1, Q2, and R. Q1 positive 25 nanocoulombs, and then Q2 negative 75 nanocoulombs, and R being 3 centimeters. So to convert, we have conversion factors again. 1 nanocoulombs is 1 times 10 raised to negative 9. So simply, the given Q1 would be 25 times 10 raised to negative 9 coulombs, and then Q2 is negative 75 times 10 raised to negative 9 coulombs. And then R, centimeters to meters, would be 0.03 meters. Now, we can substitute the values in the equation. Okay, so it would be the force exerted by Q1 on Q2 as stated in A. That would be the force to the right or to the left. So before we continue, in A, it says force exerted by Q1 on Q2. So what force would that be? Is it the force to the right or to the left? If your answer is to the left, then you are correct. Okay? So the force to the left is the force exerted by the positive charge on the negative charge, or exerted by Q1 on Q2. It's this one. Okay. Right. So Q1 is exerting the force on Q2. So that's why our subscript is F sub 1, 2. Force of charge 1 on charge 2. So it's a force to the left. And then we will write in our equation the constant, the Coulomb's constant, then Q1, Q2. Okay, take note that we consider absolute value of the charges, because regardless whether they are positive or negative, the electrostatic force, the magnitude of the electrostatic force would still be the same. Okay, so it wouldn't matter whether they are positive or negative. Anyways, the process is multiplication. So r squared, and then we substitute. K is, again, 9 times 10 raised to 9 Newton meter squared per Coulomb squared times 25 times 10 raised to negative 9 coulombs times 75 times 10 raised to negative 9 coulombs. Notice that I omitted the negative sign already because we are only considering absolute values. All right. So next, divided by 0. Done. Okay, it's back. Apologies. So, moving on. So let's say we have this given, and we have substituted already the Coulomb's constant. Q1 value 25 times 10 raised to negative 9. Q2 75 times 10 raised to negative 9. Positive because of the absolute sign. Divided by the distance, which is, wait, which is the converted value 0.03 meters squared. Do not forget the squared sign. And then if you do the math, if you type this in your calculator, the answer would be, okay, give you some time. All right, 0.01875. Okay, now what would be the unit? Obviously, since we're looking for force, that would be newtons, right? But just to do the dimensional analysis, we have coulombs here times coulombs. That would be Coulomb squared. That will cancel the Coulomb squared here in the Coulomb's constant. And then we have a meter squared as the denominator. This will cancel the meter squared on top. And that would be, what's left is newtons. Right? So to round off the two non-zero numbers, so our force, or the force exerted by Q1 on Q2, would be 0.019 newtons. Now, to answer letter B, which is the force that charge 2, Q2 exerts on Q1, by law of interaction, okay, the magnitude of exerted by Q2 on Q1 would be the same as or equal to the force exerted by Q1 on Q2. Okay, so the two forces here are equal in magnitude but opposite in directions. So you don't have to solve for it anymore. So for letter B, you could just write the force exerted by charge 2 on charge 1 would be approximately also equal to 0.019 newtons. All right, so these are the answers. Now, okay, so here's my computation. And then here is the much clearer solution. Now, in the worksheet that you will be working on, please take note that you might solve for not just the force, but for the value of Q. For example, the formula is F is equal to K, Q1, Q2 over R squared. So what if the unknown is one of the charges? If that is the case, you'll have to derive, okay? Derive the equation for the unknown charge. That could also be, other case could be R is the unknown. Okay, so derivation is needed. Now, you divide the class into 6, and then you will receive the worksheet. Okay, you can answer up to how many items you can in this period, and I will be collecting the hard copies next meeting. Okay, so that is all. Thank you so much for listening, students. I'll see you again next week. Thank you.